All right, the last section in Chapter 7 is some application and real world examples for dot product and cross product. So hopefully maybe answering a question why are we doing dot product and cross product with vectors here. You'll see a couple of physics-based applications, work calculations, force, a discussion of force again, and just a couple of different area and volume questions. So first up, we got to just discuss a little bit about the definition of work. And so work is the product of the distance of an object that's been displaced and the component of the force along the line of displacement. So here's an example of work. Someone pulling a sled using a rope and sliding along an angle, sliding along the ground, but at an angle where the force is being applied here. So we can calculate the work involved in doing this by taking the dot product of the force vector and the displacement vector, and we can take those values, right, and sort of do the cos of the angle in here. So force, we know magnitude of force is measured in newtons. Distance for the work formula, distance has to be in meters, and work generates a joule thing. So joules measurement for work is really just a Newton meter in a lot of cases, and I think that probably sounds familiar with some of you guys with some work that you've done in physics and in science. Okay, so let's do one here. Okay, a box is pulled on a horizontal distance of 10 meters. Okay, so we've got our distance in meters, right? Okay, okay, so we've got our distance in meters. That's good. At a force of 500, so we've got our force of 500 newtons at an angle of 30 degrees, and we've got an angle given here. So we use the work mass to calculate the work. So that's just going to be a very straight application, okay, of the given formula here, where I'm going to put the force of 500, the displacement of 100, and then the cosine of my angle. Okay, and that works out to be cos of 30, okay, is a special triangle here that I'm just going to put the ratio in. I think I've got cos of 30 is root 3 over 2. If you get that, if you get a decimal in your calculator, that's fine. I don't need my calculator work here. This can be 250 root 3 joules is my units. Okay, and now that's again, if you want a decimal approximation, I don't know exactly what it is. I'll do that quickly, but I'm fine with you leaving it as the textbook leaves it. Okay, that's just as a radical. I've got approximately 433 for any students that have done that, evaluated that. Okay, so that's it. That's a straightforward application. Okay, there'll be somewhat changes to it a little bit, maybe a different way to look. And this is the next example. Marianne is pulling her daughter on a toboggan. It's exerting a force of 40 newtons, acting at 24 degrees to the ground. Marianne pulls the child a distance of 100 meters. How much work is being done? Again, it's going to be a work calculation, same formula. So we're going to do force times displacement, and then the cos of this angle in particular here, that's going to be 40 times 100 is in meters, and then the cos of 24. This has to be a decimal approximation. We don't have a nice basic trig ratio for the cos of 24, so that'll be 3,654 joules is what I have here for this one. Okay, so be prepared for questions like that, where we're going to talk about, okay, just calculating work done on a sort of a physics based type of example here. Okay, torque's another common example when we talk about cross products and dealing with vectors. So torque is described as a turning effect. Okay, so it's the force that's placed on a point M, okay, defined to be a vector. Okay, so the torque, a rotational or turning effect about a point A, more specifically, is created by a force F. Okay, that force vector, for some reason it's misplaced there, acting on an object located at B. At point B is given by the following. Okay, so torque, okay, is the cross product of the displacement vector, okay, so the distance between points A and B, okay, multiplied by the force that I'm applying that. Okay, so if I have, let's say I have a situation here where I've got point A and point B, I find okay, the R, okay, the R vector between points A and B, and then I apply this, I take a cross product, so I apply this, okay, on this force. So what happens here is that, okay, this force, vector force, okay, is being, okay, applied to this displacement vector by way of a cross product, and it generates a torque. So think of the corkscrew example that we talked about yesterday, or if you like, a wrench. Okay, so if I apply my force, okay, here at this angle at the end of the wrench over this distance, obviously there's going to be a turning effect or a torque, okay, that goes, okay, into the screw at the end of this wrench. Okay, so my point of rotation, okay, is B, or in this case it's M, and there's a downward, okay, or perpendicular to the plane if I apply that force. Okay, so a lot of the resultant vectors here, and again, it's going to be cross product, it's a resultant vector, okay, is going to be like a downward perpendicular. Now if I apply the force the other way, okay, it's going to, okay, do a reverse effect on that. So that's kind of the difference between just doing these cross products in a different or reverse way. Either way, this is what we're going to use for torque. Okay, and torque is measured, torque's a magnitude, because it's a, okay, it's a similar to mental work here, in a lot of cases. Okay, so it's, again, well, it is, because it's a joule, it's a calculation of joules. Torque is represented by joules as well. Okay, so here's an example. I think we've got enough information here. So my wrench is 30 centimeters long. Okay, now 30 centimeters long, first thing I have to do, okay, is this 30 centimeters, convert it to meters, and that's going to be my R value here. Okay, it's used to loosen a bolt by applying a force of 20 newtons. Okay, at an angle is indicated by that, and it's the angle, okay, is all the given angles, okay, okay, is shown here 30, but this angle that we're doing is this force here. We've got to do this angle and use this angle. Okay, so our torque, okay, we're going to do the calculation R times, okay, F, and then the sine, okay, of that given angle here, and I'm going to find that to be 0.3. The force we said was 20 newtons, and it's going to be the sine of 150. I get that full product to be about 3 joules. Okay, so that's the torque, the magnitude of the torque that's placed on that bolt at the end of point A here. Okay, thing that I have in my notes here is a common question for torque is maximum torque. Okay, so what we need to know about maximum torque, and we can achieve maximum torque when we apply a force at 90-degree angles. Maximum torque is always achieved at an angle of 90 degrees. So if I'm pushing this, I want to push at 90 degrees. Okay, so two things let us achieve maximum torque. It's the very end of, okay, the distance, so the longest distance, because maximum or torque is this distance value, right? So the bigger the distance, okay, the more maximum torque I'm going to get. In this particular case, we still have force, okay, and we'd have sine of 90 degrees in this case. So in this particular example, okay, I could rearrange my force applied. I could move this force to a 90-degree angle, still be at this farthest end, and actually get, okay, a situation here where I have, okay, the sine of 90. Simply by moving my angle, the way I apply the force, I could get a lot more torque on this. I could double my torque, so if just 6 joules I could apply, again, simply by keeping the same distance down that wrench, but applying that new angle. Okay, parallelogram area. Area of a parallelogram, okay, is defined by 2 vectors and then the sine of the angle. Okay, and we've kind of seen this idea here in this parallelogram law, and we can take the cross product of these 2 vectors and find the magnitude of it, or we can use the magnitude of A times the magnitude of B times the sine of theta. Either way, I don't really need always the angle, I can just use my vectors. Okay. So let's find the angle, the area of this parallelogram defined by the two vectors. So what I want to do for this particular example is take the cross product. Okay, the cross product of the two vectors. I'm going to do that, and I'm going to find the area, okay, of the parallelogram, and I'm going to use, okay, that formula here. So I want to take the cross product of 1, negative 1, 0, cross 0, 1, 2. Okay, so what I want you to do now is pause your video and actually calculate over the margin, calculate the cross product. Now, please try and do that mechanically, right, with the steps I showed you, right? Okay, over here I could go negative 1, 0, 1, and then back to negative 1, and I could go 1, 2, 0, and 1. That was just here, 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 and then for the second vector, just I'll column 1, 2, 0, 1. Okay, so do the cross product. Okay, do that. And I'll return. You guys can pause it and do this calculation, and I'll return with my cross product answer. All right, here's the cross product that I got. And if you did not get this, check your calculations again, or go to a cross product calculator online here. Now the magnitude of this is 4 and 4 and 1. Okay, so that's the square root of 9. Okay, or we know that to be 3. Okay, so the area of this parallelogram, sorry, I'm just going to call it square units. Okay, so that's not a hard calculation to do here when I'm given vectors. I think we've got one more. I think I know which one this is. All right, area of a triangle. So we do the same type of thing, except it's involved a little bit more work. I'm going to have to find A and B first. Okay, when I'm given my points in my triangle, okay, I want to find B, vector B. So I'm just gonna label this. Okay, let's go A. Actually, no, let's follow proper sequence here. Okay. Okay, so I'm gonna call this A because it's across from my vector A. Might as well. I'm gonna call this A, and I'm gonna call this one B. Okay, and this will be C. So I need vector A. Vector A is going to be CB, and I need vector B, and that's going to be the vector CA. Okay, so I'm going to use these points and find these vector systems. I'm going to take the cross product of it, then take the magnitude of that cross product vector, and then take half of that. Okay, a triangle by its definition is a half of a parallelogram. Okay, so first things first, I need CB here. Okay, so CB, I'm going to write it up here. CB, I end up at B and I start at C. So I'm going to go negative 1, take away 1. That's 2, negative 2. Okay. So 0, take away negative 2 is positive 2. Okay. And then 0, take away 2. So I might have messed this up here. Vector, so sorry, I'm just going to double check this. So I take B first. So negative 1, take away 1 is negative 2. 0 take away negative 2 is positive 2, and 2 take away 0 is 2. Okay, B is the vector CA. Okay, vector B is the vector CA. So I'm going to take A first. Okay, that's 0, take away C. So 0 take away 1 is negative 1. 1 take away negative 2 is 3. And then 2 take away 0 is 2. All right, so I have these vectors here. That's going to be vector CB cross vector CA according to my diagram here. Okay, and that's what I want because I have this angle here. All right, so I've got, I've got cross product of negative 2, 2, and 2 cross negative 1, 3, and 2. Okay, I'm going to pause. You guys can calculate that. Okay, go for it. Okay. I actually have to do it on the side. I don't have this one in my notes. I'm going to go 2, 2, negative 2, and 2. Okay, and then 3, 2, negative 1, and 3. So I'm going to go across here, so that's 4, take away 6. Okay, negative 2 plus 4, negative 2 plus 4 is 2. Okay. And then I've got, okay, negative 6 plus 2. Okay, so that'd be a negative 2, right? So that's going to be a plus 2. Negative 6 plus 2 is, okay, negative 6 plus 2 is 4. Okay, just double check here. Okay, and so negative 6 plus 2 is 4. Okay, now I need magnitude. Okay, that'll be 16 and 4, and another 4 is 24, so the square root of 24. Okay, I think I can, okay, take the square root of 24. I think that's 2 root 6 multiplied by a half. So my area here of my triangle is going to be root 6 square units. What I've got here. Okay, good. That looks like it's the last example here for finding the area given points. Okay, and you're working through it like this as well too. Okay, that's it. I think I'm just going to check and double check, but I think that's it for some homework questions and some review exercises. Obviously, they're optional here. And at the end of chapter 7, we have a review assignment that I'm going to make sure that you guys work on and go. When we see each other again through the next video, we'll be into chapter 8. So long, good luck.